Hello and welcome to part 2 of my adder CPD talk, What Adders Need. So, in this part of the talk, we will look at the habitat components that are essential for a population to survive and flourish, and the function each component serves. I must stress that although I've been able to provide some photographic illustrations of specific phenomena, the greater part of the narrative that follows is not based on my own data, but it's a collation of accounts across grey and white literature that represent the best available evidence. Starting with an overview, adders are long-lived, with 26% of a population studied by Phelps being over 25 years old. However, despite their relatively long lifespan, they are not territorial in the strict definition of the term, but are faithful to a particular home range. To explain, a resident population does not defend their home range from other adders attempting to immigrate, and work by Hodges and Seabrook, amongst others, suggests gene flow is achieved by a proportion of young snakes emigrating each year. Both Vitanen and Prest, in their individual landmark studies, describe the home range encompassing 3 separate areas, comprising the hibernation site, the lying out area, and the hunting grounds. The hibernation site is the mothership or hub of the home range and holds one hibernaculum or several hibernacula in close proximity. The lying out area acts as both mating site and nursery, in which hunting does not generally take place, or at least only to a limited extent. And the hunting grounds. These are where non-breeding females and males feed. And this is where you find out why there's a large gap in the slide between the lying out area and the hunting grounds. Well, it's because there is a large gap in real life. And to move between the lying out area and the hunting grounds, the snakes require sheltered migration routes that are reliable in the landscape from one year to the next. Within the lying out area and hunting grounds, the snakes require dens, in which to take shelter overnight and during the day if conditions are unfavourable. There are, therefore, 5 components to every home range, comprising hibernation site, lying out area, hunting grounds, migration routes between the lying out area and hunting grounds, and dens in the lying out area and hunting ground. There are probably dens on the migration route as well, now I think of it. If any one component is removed with no alternative available, the home range will be unviable and the adder population will go extinct. So, what are we looking for? Starting with the hibernation site, each individual adder population hibernates in one communal hibernation site, within which there may be just one hibernaculum or several discrete hibernacula. To explain, some accounts describe the sexes sharing one hibernaculum, and others describe males and females hibernating apart in separate hibernacula. This is an overview of a site in which my data suggests that the females are biased to a hibernaculum in the north and the males are biased to another in the south. And as we shall see, they all meet in a lying out area between. So, the mesoenvironment commonalities of the hibernation sites have been described as encompassing raised and therefore dry ground that's protected from winter waterlogging, an extensive southerly aspect, and thick vegetation including scrub and trees that's often, but not always, impenetrable. This description appears to be the fundamental Goldilocks niche, and as with everything in nature there are tolerances, so raised ground does not appear to be an absolute requirement. Hibernacula do occur on flat ground where there are crevices, etc. However, it's more common to find hibernation sites where there's raised or sloping ground, such as chamilai, vegetated sand dunes, railway embankments and long-standing quarry bunds. As all my experiences relate to quarry bunds, that's all I can show you, but I can say that the bunds on the top and bottom of this slide are both on the same site and both have adders on them very early in the spring. Having spoken to the locals, I'm confident that both are hibernacula on the same hibernation site. Furthermore, I find males aggregated in particular situations on the bunds shown in the top images, and if I go later in the year, I find females aggregated in certain areas of the bund shown in the bottom image. I would point out that these are snakes exploiting corrugated steel and onduline that I've deployed specifically for them. I would also emphasise I chose adders as a CPD project partly because I was intrigued by the presence of only individual sexes on these bunds. Getting back to the published accounts of hibernation sites, the vegetation cited is overwhelmingly acid, and from large to small the species cited comprise combinations of downy birch, willow, sessile oak, conifers, amongst gorse, which appears frequently, as does heather, cross-leaved heath, bramble, bracken and purple moorgrass. As an aside, studies outside the UK also report adder hibernation sites and lying out areas typically occurring on acid habitats, but hunting grounds occurring in neutral to calcareous habitats, with the snakes moving between. I'm not going to go into any more detail about hibernation sites in this talk, but my CPD report does give the detail, including some useful micro characteristics, the use of small mammal refuges, numbers of snakes within an individual hibernaculum, depths, other species that may share the hibernaculum with the adders, and a whole lot more. So, moving on, the next part of the adder home range we will look at is the lying out area. Now, upon emerging from hibernation, both the males and females initially bask in close proximity to the hibernaculum, before moving into individual basking sites in the lying out area, which is in the wider locale of the hibernation site and typically contiguous with it. Putting this in the context of the bunds we looked at earlier, the lying out area is between them and shown shaded purple here on this slide. The bund occupied by the females is the northern one at the top of the figure. The bund occupied by the males is the southern one at the bottom of the figure. The lying out area serves three functions, comprising an initial warm-up area in which the snake's metabolisms make the transition from torpor to activity, the mating area, and the maternity ward, within which breeding females will remain that year whilst pregnant before returning to the hibernation site to give birth. Now, prior to doing this CPD project, I knew I had sites with adders on them, but I didn't know that different areas had different functions, and it was only in retrospect that I got my eye in for what lying areas look like. My perception is that there are two factors: aspect and neglect. In terms of aspect, you're looking for a parcel of land that's south facing, not necessarily steep, just open to the sun throughout the day. So you're looking for an open area of ground that lacks shade on the eastern, southern and western margins. There can be tree cover on the northern margin, and there very often is, but the less there is on the others, the better. In assessing the value of a particular parcel of land to adders, and then when deploying cover objects, reptile refugia for surveillance, I have more than once overlooked the fact that the Earth spins, completing one rotation every 24 hours, and that the sun actually rises in the northeast and sets in the northwest. To ensure I take this into account, the times and degrees for sunrise and sunset, as well as the times of solar noon on the first day of each month, are presented in my CPD report with this figure, which puts the sunrise and sunset degrees into a visual context. I take this with me, and I take a compass so I can remind myself. I do this because unless the reptiles are on a totally flat and bare plateau on the top of a hill, the solar radiation will be heating the ground in different places at different times due to the topography and vegetation. From April through September, a slope with an east-west alignment that's open to the south will actually get the sun on the northern side first thing in the morning and last thing in the afternoon, evening. In fact, the sun's only on the southern side from mid-morning through to mid-afternoon, although the duration of this will vary depending on the month. Equally, any linear barrier, like a hedgerow on a north-south alignment or a bund, will see solar radiation on the eastern side in the morning, on the top and sides at midday, and on the western side in the afternoon, and the snakes move in response to this. The final point is that from April through October, the middle of the day is not 1200 hours. In fact, it's 1300 hours, So when attempting to divide the day, this halfway mark should be taken into account. Now, taking our sun discussions into account, you can therefore have a lying out area on a narrow section of land on a steep south-facing slope, which would be on an east-west alignment, as in the example on the left, or on a long section of land on a gentle south-facing slope that's on a broadly north-south alignment, as in the example on the right. But an additional requirement appears to be neglect. In the spring, at the start of the mating season, lying out areas just look rather untidy and neglected. Mosaics of acid, birch scrub, gorse, purple moorgrass and heather with patchy bracken. Or sometimes on land where someone's attempted to improve the sward for agriculture and then given up, so that there's an uneven tussocky and scruffy grassland with beds of tall ruderel, scattered low thorn scrub and bramble. The ground may be variously damp and dry, and the vegetation is typically a pig to map. Having found 3 of these myself and seen others that had been mapped by other people, I was thinking, this all looks rather rubbishy. And then I realised that was the point. Looking at the vegetation, it struck me that because it was acid and on uneven ground, despite the neglect, the vegetation structure was for the most part low, but complex to the point of being hard going to walk through. Good lying out areas are uneven and will trip you up and twist your ankle. You're looking for hummocks and hollows, ant hills, patches of dense but low gorse or thorn scrub, straggly bracken or bramble, and a varied hydrology from arid to damp. If you can easily mow the site and you're not getting irritated trying to move through it quietly, then you're not in a good quality lying out area and should focus your search on those areas where you might trip up. So, where are the snakes in all of this? And how do you know you have a lying out area from survey data? Well, the males start to emerge from the hibernaculum first, and when the maximum daytime temperature reaches a consistent 6 to 8 degrees centigrade. This may occur by the end of February, but it's still more usual in March. After about a week of basking together in the immediate vicinity of the hibernaculum, the males gradually move out into the lying out area to take up individual basking sites within around 200 metres of the hibernaculum. The females start to emerge later, when the temperature is higher, typically a consistent 90 degrees centigrade. So the female emergence typically starts 1-2 weeks later than that of the males, and the males tend to have moved away from the hibernaculum before the females appear. Therefore, if you find males aggregated in a relatively small area in February-March, you can reasonably assume you're in the hibernation site and actually at the hibernaculum. And if you return in about 2 weeks' time, you may find the females in the basking places that have been occupied by the males. But if the females are not there, then there may be another hibernaculum somewhere nearby. Equally, if you find one male in March-April that's in the process of shedding his skin, you should consider the potential that you're in a lying out area and widen your search to see if you can find other males and maybe females too. This is because if both sexes are occupying the same hibernaculum, the females move through the basking sites occupied by the males to take up their own basking sites further away from the hibernation site. The part of the lying out area occupied by the females in the early part of the year also serves as the mating ground, and each adult population uses their own traditional mating ground every spring. Females typically breed and give birth every other year, but they may delay for 2 years between mating. This is typical of snakes in temperate regions, but I didn't know it prior to doing this project. So, females that will mate that year, hereafter referred to as the breeding females, will remain within the lying out area for the entire active period of that year. In contrast, the females that will not mate that year, hereafter referred to as the non-breeding females, will migrate to the hunting ground prior to the mating season commencing. As the ratio of males to females is broadly equal, the lying out area is therefore typically occupied by twice as many males as females prior to and during the mating season, hence the fighting. And at this time, around 75% of the adult population may be in that one little area. After the snakes have mated, the pregnant females will spread out more widely into the lying out area so that they occupy their own little territories over the full extent of the available habitat. As a result, suddenly there are now only female snakes present, and they represent around 25% of the adult population, because the males have joined the non-breeding females in the hunting grounds. There are numerous inferences in historical literature that hibernation sites and lying out areas are typically on acid soils and hunting grounds are on neutral soils. For example, the masterwork of Ian Prest, in which he describes the non-breeding females and males dividing their year between heath and floodplain. However, only recently did Bowens and Klaus specifically hammer the point home that adders split their year between two very different biotopes, the hibernation site and lying out area being typically free draining on acid with poor fertility, and the hunting ground being damp and neutral with high fertility. This is because adders overwhelmingly predate small mammals, as demonstrated in detail by Ian Prest. These are creatures of the grassland and hedgerow for the most part, and they're mostly taken at the suckling naked stage in the nest. Yes, a relatively high proportion of prey does comprise common lizards, up to 30% of the diet, and some amphibians are also taken. They even climb trees to predate nestling birds, and there's some fantastic photographic and video accounts of this behaviour online. But over the summer, the snakes are focusing on little mammals, and they're taking them in neutral biotopes. And adders also need to drink, and they visit streams, ponds and puddles during hot weather. This is important. The adder is not a desert species, and although it may occupy a hibernation site in dry heath, the species can only remain in arid habitat where there's some standing water. In terms of the broad characteristics, the most repeated phrase in descriptions of hunting grounds is floodplain meadow. In the historic literature, authors such as Appleby speak of the adder being found in abundance over the summer in areas that are waterlogged from autumn through spring annually. After this, the inference is again one of neglected situations, in particular abandoned arable and pasture. Now, if the snakes are exploiting acid biotopes in winter and spring and autumn, but non-breeding females and males are exploiting neutral biotopes in summer, there must therefore be migration between the two. Migration distances have been calculated to be between 100 to 500 metres, so anything up to half a kilometre, through what may be to the adders a barren and hostile landscape. To navigate safely, the snakes exploit sheltered corridors and avoid open ground. Typical features exploited comprise ditches, banks and hedges, powerline wayleaves, woodland edge, and providing sunlight reaches the herb layer, rides, racks and tracks through conifer plantations and orchards. These situations are identical to the sort of linear landscape elements exploited by bats, only with adders the migration takes place in daylight. Different studies have reported varying patterns in migration direction. There is, however, consensus that migration routes are traditional, and the same routes are followed by the non-breeding females and males every year. There is also broad agreement that the loss or severance of these traditional migration routes may have catastrophic consequences for the adder populations that depend upon them. In this respect, the impact may be considerably more difficult to mitigate than, for example, the severance of a hedgerow used as a commuting route by bats. Furthermore, the importance of a corridor feature or linear landscape element as a migration route for adders is much harder to establish than it is for bats, because the snakes make no sound, they're superbly camouflaged, and wherever possible they're moving through and under visual clutter. And when they aren't moving or basking, they hide in surface and subsurface situations that are actually a lot harder to find than bat roosts, because where the bats are exploiting situations that are above head height, the adders are exploiting situations that are below your ankle. Which leads us to the fifth vital component, the dens in which the adders take shelter overnight, and also during the day if conditions are unfavourable. Please note that this illustration is not a photograph, but was generated using AI to visually interpret several descriptions in journal papers. So, dens are distinct from basking places. A basking place is a comfortable place to lounge about in, and the best of these are carpeted with mosses or soft grass, such as Melinia, and with low cover in immediate proximity so that the snakes can move between shade, dapple shade and full sun to regulate their body temperature. This movement's continuous in that basking place in response to cloud movements across the sky, light breeze, etc. And the snakes will also alter their body attitude, coiling, looping, straightening, to maximise the radiation whilst mitigating predation risk. I've reviewed the available evidence in my CPD report, and my perception is that basking glades are typically small, often around A5 in size, so about 31 centimetres squared. But, moving back to the matter in hand, adders are diurnal, and the descriptions in the literature as well as my own data lead me to conclude that in comparison with all the other native reptiles, they're actually pretty lazy, late rising and early to bed. When they're inactive, adders exploit both surface, i.e. above ground, and subsurface, i.e. just below ground, dens. Now, in the literature we're told of large features that are exploited, such as dry stone walling, particularly where it's in a wide unmanaged verge or arable insecticide, and log and brash piles, particularly where they're overgrown with bracken or bramble. But this tells us very little about the actual den. It's rather like saying bats roosted trees. Well, yeah, they do, but where in the tree? In the literature, when you get right into it, the suggestion is that adders exploit the runs and nest site of their prey as surface dens. Features cited comprise dense vegetation such as grass tussocks, clumps of rushes and reeds, large stones, and even dry leaves if they offer a depth of at least 10 centimetres. The grass tussock description appears sufficiently often for me to have started investigating them myself. Here we have a perfectly ordinary Melinia tussock, but if you search these you very often find a small mammal nest in the base, slightly raised from the ground and in a pita bread sized pocket, just the right size for a vole family and just the right size for an adder. This one did not hold an adder, and I confess I've yet to find one that has, but it does fit with the published descriptions. Adder goes in, eats occupants and takes over the nest site as a den. Unfortunately, there are very few photographs of surface dens out there, but there is a really useful paper by Nigel Hand from 2019 titled The Secret Life of the Adder Revealed Through Telemetry, which has photos of dens beneath bracken thatch and in the runs and shallow sheltering situations exploited by nesting field voles. I recommend it, it's well worth a look. Moving on, in terms of subsurface dens, situations cited include smaller entrance passages, such as amongst roots of leggy mature gorse and simple crevices in peat. There are even fewer photographs of subsurface dens out there than there are of the surface dens, and I'm afraid I've personally only found one, and here it is. Now, this den was under a 60 centimetre square of corrugated steel refuge, so it may be anomalous, but it's all I have, so I'll show you some of the 1,000 or so photographs I took of it. Right. The male snake was half in and out of the den when I first encountered it, and I was at an angle where the entrance faced away from me as the snake retreated inside. So I left it to settle for a couple of hours, during which the sky clouded over. The snake had plenty of time to go about its business, but when I returned, looking from a better angle, it was still visible from outside the entrance hole. So I left it again. Now I was also checking a stack of tree roosts that day for bats, so I had my endoscope with me, and this was fortuitous, because when I went back at the end of the day the conditions were a lot cooler and the snake was not visible. So I took my endoscope and I put that in the entrance to find the snake still in the den, and now right at the back of what was a shallow pocket, about the size, I estimate it was about the size of a medium-sized doner kebab. The den being under a surface refuge hardly counts as being natural, and I didn't go back at night, and I do regret that because I cannot conclusively state that it was occupied, whether or not it was occupied overnight. But it's clearly in a mouse vole nest site, so it fits with the literature in the sort of places the snakes exploit. Now, I'm going to pause here with a recap of what adders need before we look at the annual adder relay, which for me was where I really got to grips with how this species works. Okay, so we've now established that there are 5 components to every adder home range. We've looked at the hibernation site, and we know that this is the mothership or hub of the home range. We've looked at the lying out area, and we know that this acts as both mating site and nursery. We know that female adders typically mate every other year, and those females that are not breeding in any particular year decamp to the hunting grounds as soon as they emerge, and will be joined by the males later. Here, the non-breeding females and males will spend the summer. And we also know that to move between the lying out area and the hunting grounds, the snakes require migration routes, and these are traditional routes which have been reliable in the landscape from one year to the next for a very long time. And finally, we know that adders take shelter in dens. And although the literature is full of broad suggestions of where to look at the mesoscale, aside of one Scottish paper, there really isn't much to go on at the microscale. So someone can make a name for themselves doing adder den habitat key. So, 5 components, all of which fit together as one home range. And here, I suggest you pause for a comfort break. Make a fresh cup of tea, etc. Have a biscuit, perhaps take a moment to download the detailed report. And if you think I've misunderstood any aspect of the subject matter so far, now is a good time to fire off an email to me using the contact page on my website to tell me where I'm going wrong. I am going to have a mouthful of water. Okay, got your tea? Got a biscuit? Excellent. Sit back and relax while we romp through the annual adder relay. Why do we do this? Because once we understand what adders are doing at different times of year, we can interpret the function of a particular function of habitat when we find them in it. And that may inform a prediction of where the other components of the overall home range might be in the wider locale. Be aware, the account I've created is based on the work of other people. I'm just presenting it to you in a format that I produced for myself as CPD. This was so that I could understand it all. What we'll now romp through in a matter of minutes is an overview of a massive body of evidence collected over decades by herpetologists from a multitude of countries. So, on the starting blocks, all the snakes are in hibernation in the hibernation site. The adder is the UK's most cold-tolerant snake, and the males begin to emerge from the hibernaculum within the hibernation site when the maximum daytime temperature reaches 6 degrees centigrade. It takes about 7 days for them all to emerge, and after a short period of communal basking, they disperse into their own individual basking sites within the lying out area before the females start to emerge. These individual basking territories are respected, and the males are sedentary within their own particular territory within the lying out area. The females begin to emerge about a fortnight after the males, and when the air temperatures reached about 9 degrees centigrade, and their emergence takes much longer. It may be up to a month before all have left the hibernaculum. The males, having already taken up the available lying out area closest to the hibernaculum, means that the breeding females have to move through and beyond the males to find vacant areas in which to establish their own individual lying out territories. While the breeding females take up their individual basking territories within the wider lying out area, the females that will not breed that year immediately disperse to the hunting grounds. The non-breeding females having departed from for the hunting ground, only a proportion of females remain in the lying out area, and these spread out and bask prior to mating. In April, the males undergo their first slough, and when that sloughing is complete, the males are conspicuous in their breeding livery, after which they're alert, aggressive and begin searching for the females, which have all now emerged by mid-month. The males therefore move from their basking territories close to the hibernation site and on out into the part of the lying out area occupied by the breeding females. Here the males will fight for the right to mate. Mating commences around mid-April. It's at its peak at about the end of the month and into May and lasts for approximately 3 weeks overall. During mating, the females are sedentary but not static. They move around within their limited parcel of ground. As each female remains in her own little territory in the lying out area, the males move more than the females and are conspicuous by their ritualistic fighting. Having mated, the males leave the lying out area and migrate to the hunting grounds and join the non-breeding females just as they're finishing their first slough, while the breeding females spread out in the lying out area to occupy their own pregnancy territories, and they then undergo their first slough. Throughout the summer, the breeding females will remain in their own small pregnancy territories within the overall lying out area. Meanwhile, the non-breeding females and males range widely in search of prey within the hunting grounds. The males commence their second slough around the end of June, and then from the end of July both the breeding females and the non-breeding females begin to undertake the second slough, with a peak in late July, early August. After this, around the end of August, the breeding females return to the hibernation site where they slough and give birth before heading back into the lying out area to hunt, and at the same time the non-breeding females and males begin to make their return migration and go straight through the lying out area to the hibernation site, where they'll typically bask and generally loaf about for a couple of weeks before entering the hibernaculum. The summer being over, as the daytime temperatures drop to a point where the females that have bred that year can no longer profitably hunt in the lying out area, they return to the hibernation site, and they go straight into the hibernaculum without waiting to bask. And so the year is at an end. The population is back at the hibernation site and all in torpor underground in their hibernaculum, where they'll remain until the following spring. Now, that is a lot to remember. So, I created a tabulated summary that I can use in the field, and I put that in my CPD report so you can have it too. And as I want to time some visits to my remoter sites to be able to catch the snakes at what I think are at the hibernacula within the wider hibernation site, I also created a temperature guide for predicting the end and onset of hibernation, and I put that in the CPD report too, so you can have that. And this brings us to the end of the adder relay, and we now understand that males and females behave differently, and females behave one way when they're mating and another when they're not. As a result, when we find males and females in a particular parcel of habitat, that will tell us the function of that habitat to the population, and we can then look more widely for where the other components of the home range are likely to be. Here's an example. I've done this one quite a lot now, but I found the lying out and mating area first. Although I only knew that that's what it was after I'd done this CPD project. Females were present from April through September. Males were only present from March through May, and the habitat is the typical acid mosaic. Having established that, I worked out that the most likely hibernation sites were in the buns at both ends, also typical acid habitat. I tested this hypothesis and I was not wrong. Although, in fact, I found the females first and was really puzzled because I couldn't find the males, and that's part of the reasons why this whole thing kicked off. I started searching for the males, and yes, there they were, somewhere else, in the southern one, so part of the same hibernation site, but away from the females. Not all of them, but most of them. So, I can therefore widen my consideration by knowing this to look for the sort of undisturbed neutral habitats that might deliver a source of prey and be exploited as hunting grounds. And lo and behold, here we have 2 river valleys with flanking rough grassland. Explored that. Looks superficially superb to me. And that led me to think about where the migration routes might be and look for any obvious bottlenecks. All of these would be worth sampling to test my hypothesis in respect to the hunting grounds. And that Here's the end of part 2 of my CPD talk, and leaves us neatly into my approach for searching for adders, but this is also a convenient place to pause for another comfort break, or to download the detailed adder report, or for you to contact me about anything you think I've misinterpreted or just got plain wrong. And if after the break you want to continue with the talk, you can find it by searching for Henry Andrews Adder CPD Part 3. Thank you for listening.